Geometry, Unit 2, Section 4, Unknown Angle Proofs. This is really our first introduction into what proofs are, and this is a really important concept in geometry. You're going to ask to prove things throughout the year, sometimes in what we call a statement reason proof, which is kind of what we'll do today for triangle congruencies and things like that. But we're not there yet. What we're really trying to do is prove things that you kind of already know. Like in this case, we want to prove vertical angles are congruent. And you know that vertical angles are congruent, but why? And so we're going to attempt to create a proof that proves that vertical angles are congruent. So even though you know that right now, you need to kind of pretend you don't. And so let's talk about what we could possibly do. And a lot of this here is the language, the notation. That's what really makes this important, because if you're not careful with how you say it, then you might kind of open your argument up to interpretation, which would not be a good thing. So, all right, you know that the sum of angles on a line is 180. So we are saying we know that. We know that these two angles add to 180. And that's the first thing that we're kind of saying here. Make a plan. What do you know about W and X? Well, I know these two angles add to 180, and I know that these two angles add to 180. So how does that help me prove that this is congruent to this? How does that help me prove vertical angles are congruent? And basically, if these add to 180, if W plus X is 180 and Y plus X is 180, then that does prove that W and Y are the same. But let me explain why a little bit and kind of draw out what we know. So what do we know? The first thing is we know that angle W plus angle X equals 180. And it's not enough to just write that. I need to write why that is the case. And so just to the right of that, I'm going to simply say that two angles that form a linear pair, I'll go over here, are supplementary. Is that the only way to say that? No, you could probably say two angles that, I don't know, we could probably do something like collinear adjacent, but it has to be two angles that form a straight line, or two angles that form a straight line are supplementary. So something like that. And under that same argument, we could also say that angle y plus angle x equal 180. And so how does that prove that y and w are the same? Because it does. So angle w is congruent to angle y. But what would be our reason? Well, if w plus x is 180 and y plus x is 180, like you could kind of rewrite this a little bit to solve for w, right? I could say w equals 180 minus x and y equals 180 minus x, and if they equal the same thing, then they must equal each other. And there's two reasons I think you could get away with here. You could either say what's called transitive property, but what most students kind of understand a little bit better is substitution. I got way too many T's in there, right? Substitution. No, I guess that looks pretty good. If I spell something wrong here, just know that I'm terrible at spelling. So substitution. Now, what I mean by that is that I can replace W and Y with each other, and it won't affect the problem, right? If I substitute W for Y, I simply am now this equation, and it still equals 180. So therefore, they are the same. So W is congruent to Y because of substitution, and this proves that vertical angles are congruent. I just proved that this angle is congruent to this angle because they're both supplementary with angle X. Let's try another one. Given the diagram on the right, I want to prove that W plus X plus Z equals 180. Well, what I know is, right off the bat, I don't know that they equal 180, but I do know that these three equal 180. Right? I know that angle X plus angle Y plus angle Z equal 180, and my reason is the three angles of a triangle sum to 180. This was supposed to be a triangle symbol here. Pretty sloppy. Let me redraw that a little bit nicer. The three angles of a triangle. I read out the word triangle also. But all right, so three angles of a triangle sum to 180. Notice that I'm using this symbol for angles, and I'm using a symbol for triangle. You know, in the previous problem, I abbreviated supplementary. Have again the angle symbol here. There's some things that you could get away with symbols, and some things you could abbreviate. Not everything though. So, oh, triangle disappeared. So three angles of a triangle sum to 180. We know that. And then we also know that from the previous proof, these angles are congruent. Angle W is congruent to angle Y because vertical angles are congruent. And we can say that now because we've proved it. So that is something we can use. Vertical angles are congruent. So how does that help us? Well, x plus y plus z is 180. So that means that w plus x plus z is 180 because I can simply replace y with w, right? If these are equal, I can replace them with each other. So I could take out my y and put in a w, and that is what I'm trying to prove here. That angle w plus angle x plus angle z equals 180. Again, by substitution. If these are equal, I can replace them with each other, and that's exactly what I wanted. So that's it. These are very short proofs. Now, is this like a property that I'm trying to prove, like vertical angles are congruent? No, and it's not always that. Sometimes it's just something like this, but we want to see if we can figure out how to prove that. Well, if these are 180 and these are the same, then I can replace these with each other, and that means that these three are 180. Let's try one more, but I got to do a correction on here. This doesn't fit this diagram. Given the diagram, prove that w is equal to y plus z. There's not even a w on this question, so I'm actually going to scribble this out and rewrite something here. Let's put a w here, and I want to prove that angle y is the sum of angle w plus angle z. So what I want to prove here is that oh no, I'm sorry. That's not going to work here. I thought that this was an exterior angle. Maybe if I put the y here, yeah. I wanted to do an exterior angle proof here. So yeah, keep that there. But let's cross out the y and let's put the y there. I'm not really sure what this diagram was meant. I don't think these problems were for each other, so we're going to kind of make it up. But all right, that's fine. This will work. So I want to prove that w plus z is congruent to y. All right. So I want to prove the exterior angle theorem we learned previously. Well, what do I know? I know that these three angles add to 180, right? So that's angle x plus angle w plus angle z equals 180 because three angles of a triangle sum to 180. And I also know that these two angles are supplementary. Angle y plus angle x, right? They add to 180 because two angles that form a linear pair are supplementary. And so you see, you're going to use the same arguments a lot. Two angles that form a linear pair are supplementary. And then I'm ready to jump to that next step. I'm ready to say that y equals w plus z. Why do you think I'm ready to say that? Well, if these things both equal 180, doesn't that mean that these things equal each other? So then I could say that angle x plus angle w plus angle z equals angle y plus angle x because of a form of substitution. if this equals 180, then I can replace 180 with this. That's exactly what I did. I substituted 180 in for what I know equals 180. And then, so what do we have here? We have x plus w plus z equals y plus x. Well, then I can simply subtract the x's away, and I'm left with angle w plus angle z equals angle y, which is not substitution, it's subtraction. And that's it. So, and I could have done something similar to over on this first question. Since they both equal 180, I could put them equal to each other and then minus x, and that would have worked that way too. So it's kind of a way of kind of showing the substitution, I think, which is a good thing to do. So that's basically about it. The three angles add to 180. These add to 180. If they both equal to 180, they can equal each other. I could subtract the common x out, and that leaves w plus z equals y, and that is our exterior angle theorem. All right, so this is going to take a little getting used to, the notation, the language, and proofs in general, but we'll practice this, and we're going to spend a good amount of time on proofs coming up. Bye.